I hope you are able to see the screen. Am I correct?
Yes, sir. Yes, sir. It's clear.
Okay. Now, as per you, in the index question, see,
Yes.
in text question, actually we are doing aldehyde, ketone, and carboxylic acids. And here we are doing the index question number 12.1. And 12.1 means the first one, I think. In the first one, what is the name of the compound? Can you read it? Alpha
That is alpha methoxy propion aldehyde.
propionaldehyde.
Okay.
Propionaldehyde. Yeah. So when we talk about alpha methoxy, clear? So anywhere the carbon chain, suppose this is carbon chain, and the carbon having the functional group, either OH or CHO or carboxylic acid, this carbon will be considered as alpha carbon. So alpha carbon is what? Carbon having OH group, functional group. So same here, we have how many carbon? Prop. Prop means how many carbon? Tell me, how
Two
many carbon
carbon.
we have? Yes, exactly. One, two, three. Three carbon. And propionaldehyde. So propional means one, two, three, and make aldehyde anywhere like COOH. This is propionaldehyde. Alpha methoxy. So since this is functional group, this CHO is functional group. So alpha carbon will be this one. This is alpha carbon, and this alpha carbon has methoxy. Methoxy means OCH3. It's called methoxy. And rest valency of the carbon will be valenced by hydrogen, CH3, CH. So this is the compound. So alpha methoxy propionaldehyde. This is the structure of the compound. Any confusion? This is the first one.
Sir, then this alpha carbon, it will be next to the functional group, or the functional group itself is the alpha carbon.
If it is written, if anywhere it is written like uh, functional group attached to the carbon, that will be the alpha carbon. Okay, functional group attached to the carbon. Since this CHO, this is the functional group including carbon. So
Yes,
this
sir.
is so the adjacent carbon is this one. So this is the alpha carbon. In the case of alcohol, this OH group, this alcohol has don't have any carbon. So adjacent of this carbon is now alpha carbon. So if the functional group contain carbon, so that carbon cannot be counted. Adjacent of functional group, the carbon of adjacent functional group is called alpha carbon. Am I clear?
But sir, in that other example where alcohol was attached, that one you marked as alpha carbon.
Exactly. So the see that here also I mentioned that the alcohol OH group attached to the carbon is alpha carbon.
Yeah.
This alcohol is only OH group, not carbon and OH is alcohol. Aldehyde is CHO. This is aldehyde. But alcohol is only OH, not carbon. In alcohol, there is no carbon, but in aldehyde, there is carbon. So this carbon is the part of functional group. So don't consider this one. This is the functional group. This is the alpha carbon. And this OH is the functional group, not this carbon, not this carbon. This OH is the functional group. So the functional group attached to this carbon, which is alpha. Am I clear? And here this HO is the functional group, aldehyde. And this attached to this carbon, which is alpha. Now, suppose if I will discuss carboxylic acid, see which carbon is alpha? Which
Sir,
carbon is alpha?
sir, I
Yes,
can't.
tell me. Either this carbon alpha or this carbon alpha. Which is correct?
Sir, can you number it?
This this entire this entire one is the functional group, carboxylic acid. So adjacent of this one is alpha. This is not alpha. Am I correct?
Mm,
Am I correct?
yes, sir, yes.
Is it fine?
Yes,
Yeah.
sir.
So that I wanted to discuss. So in previous class we were doing about the preparation of aldehyde and ketone. Am I correct?
Yes, sir.
Preparation of aldehyde and ketone. So is there any doubt or confusion, or should I continue with the next topic?
Yes, sir, we can continue.
Yeah.
Sir, if
So
I
I think
may,
in previous class, yeah,
like, just a small overview of what we learned in the previous class.
exactly. That I wanted to say. In previous class, we have completed the IPC nomenclature of aldehyde, ketone, and carboxylates. In aldehyde, suffix -al and ketone -on and carboxylic acid, oic acid can be used. Okay. Now, when we talk about the preparation, so in the case and in the structure, so in the case of structure, aldehyde or ketone or carboxylic acid, all are having carbonyl group. And this carbonyl group means oxygen is more electronegative. So this oxygen will carry partial minus charge and carbon will carry partial plus charge. So this
Yes,
bond between carbon and oxygen is polar. This is polar in nature. And when we talk about the hybridization, so around this carbon, see that around this carbon we have one sigma, one pi bond, one sigma bond, one sigma bond. So around this carbon we have three sigma bond. So hybridization is equal to sigma bond plus lone pair. Hybridization is equal to sigma bond plus lone pair. So sigma bond will be 3 and lone pair will be 0. So it is equal to 3. So sp2 hybridization. So here hybridization, since hybridization is sp2. So this carbon is sp2 hybridized. So when we draw this structure, so this will be carbon, double bond O, and this oxygen have 1, 2, 3, 4, 5, 6 electron in the outermost shell. And this carbon has 4 electron in the outermost shell, and one orbital is vacant orbital because this carbon has atomic number 6 and it will be 1s2, 2s2, 2p2. So when we talk about this first cell and this is second cell and second cell, so in the case of second cell, you can see that uh, one orbital of S have pair of electron and three orbital of P have two electron. So there are two unpaired electron. But carbon has tendency to form tetravalency. So in the case of tetravalency, there will be total four unpaired electron. So how it this is possible? So we will write the excited electronic configuration of the carbon where one electron of this S subshell will jump to P. So it will be now 1s2, 2s1 and 2p2, 2p3. Sorry. So here it will be 2p3. So now you can take S one electron and C three orbital, three electron. So when we talk about sp2 hybridization, so in the case of sp2, one s orbital and two p orbital only required. It's a
okay.
px, this is py, and don't take pz. One s and two p orbital, one s and two p orbital required because hybridization is sp2. So hybridization is sp2. So this orbital we can make it here. So this is the structure of this carbonyl compound, means carbonyl group. So this part we have done, and also I discussed about the method of preparation. In the case of method of preparation, we are knowing that we can prepare aldehyde and ketone. So aldehyde and ketone we can prepare by oxidation of alcohol, dehydration of alcohol, hydroboration, ozonolysis, and hydration of alkyne we have done. Might be you are knowing as per the chart as per the chart. I think I should show this one. Just a minute. Let me open the things where it is 24 aldehyde. 20 where it is just a minute.
Yes, sir, its name was Aldehyde 24.
Aldehyde 24. Oh, haha, yeah. Aldehyde
Yes,
24.
yeah.
Yes. Aldehyde 24. It has come. It has come. Aldehyde 24.
Yes,
So here, uh, let us. So here, when we talk about method of preparation, see. So this is the method of preparation where both method uh, is the method for both aldehyde and ketone. So by oxidation of alcohol here and by dehydrogenation, and in the second one from hydrocarbon by ozonolysis of alkene and hydration of alkyne. Here I discuss that the primary alcohol give aldehyde and secondary will give ketone. So how you have to use the mild oxidizing agent. What are the mild oxidizing agent? So here this is written. See, right? This is written. The mild oxidizing agent. Have you got it?
yes, sir, yes.
No, no.
Yes, sir, I told I got it.
Hmm. So you haven't revised, I think. You should revise it at least. You should revise. Aldehyde 24.
It's okay, sir. Now we can continue the new topic. I remember.
Okay.
Last one we did hydration of alkyne.
Okay, so here see that mild oxidizing agent, right side I have written. And the right side it is written
Yes, sir.
mild oxidizing agent. Either you can use the potassium dichromate, and it's a very direct uh, solution. And Jones reagent, chromium oxide, H2SO4, acetone. The mixture is this one, PCC, pyridinium chlorochromate, PDC, chromium oxide means pyridinium dichromate. And here it's written copper at 573 Kelvin temperature. Either you take the copper or silver also you take. So primary alcohol will give this aldehyde and secondary will give ketone. And when you do the reaction, so you can take the zero by copper. So this two hydrogen will be eliminated. So this is called dehydration. Dehydrogenation. So you will get aldehyde as the product. Then ozonolysis. So in the case of ozonolysis, just try to break the double bond and put oxygen both side carbon. So you will get either aldehyde or ketone. See that along with the double bond, how this oxygen will be added. And when in the case of hydration, see that hydration of alkyne, water is added to the carbon having less number of hydrogen as per the Marconi-Karb's rule. Clear? So when two OH is added to the carbon, so now the compound become unstable. So the carbon having two OH and that will be unstable and it will undergo hydration. That H2O molecule eliminated and it will change to the ketone.
Yes,
Yes, this part
yes,
till this part we have done. Am I correct?
yeah, yes.
Now, see the next one is
Sir,
this.
I uh, this starting preparation of aldehyde and ketone, those three methods are given. I think it is not much important, maybe because it is given very less in the textbook also. Main is, I think, preparation of aldehydes. It is important.
No, no, it's very important. Why it is given only in a simple line? Because it's already has been discussed in the previous chapter, alcohol. That's why it's written in very simple way here. So if I am explaining this one here in detail, well, I will teach you alcohol. So I will say you that you go. I will refer you to check in LDI chapter. Okay.
So, sir, if I
So if
study this part from alcohol chapter, then it is same like this
Mhm.
over here also.
Yes, yes, yes. So same here. See that you are preparing aldehyde from alcohol.
Yes, sir.
So this is the method. But in the chapter of alcohol, it will be the chemical property where you can see that the alcohol so oxidation, alcohol so dehydration, है ना? So it becomes the chemical property. So in
Okay.
alcohol, it will be in chemical property. Am I clear?
Yes, sir.
Hmm. So all the reactions, if any word is mentioned in the NCRT, it's very, very important. You have to explore more and more about that word. Okay?
Yes, sir.
Your teaching have you discussed about the Vidyarthi Vigyan Manthan? It's the Olympiad competition because I know that this Vidyarthi Vigyan Manthan is international Olympiad where the student from the Gulf country they are participating in this event. So are you knowing? Are you having any information regarding this Vidyarthi Vigyan Manthan competition?
Sir, not that Olympiad, but there are some other international Olympiads also. They tell us about it.
Hmm.
We didn't participate in that. But
You
the
haven't.
football thing, that one I'm not aware of. But yeah, other Indian Olympiads are also there. International or Indian.
Hmm. Okay.
Yes.
So see that only aldehyde. So this part we have to do today. Only aldehyde, preparation of only aldehyde.
Yes, sir, yes.
Okay. So here we have first method by reduction. So here by reduction method we can prepare it. So by reduction method, let me take the screenshot of this one so that it required. Uh, so
Sir, you have already opened that screen. Yeah.
So here in the preparation of aldehyde, see preparation of preparation of aldehyde. Am I audible?
Yes, sir. Yes.
So preparation of aldehyde. So the first one is by reduction. By reduction. So in the case of by reduction, you have to use the reducing agent. See, in organic chemistry, reduction means addition of hydrogen. There are many different definitions of reduction. But in organic chemistry, reduction means addition of hydrogen. Addition of hydrogen. So for reduction, you require any reagent which are any reagent which is supplier of hydrogen. So the reagent which is supplier of hydrogen is called reducing agent. So here we will use a special type of reducing agent. Especially what if you are using hydrogen with palladium and barium sulfate. Hydrogen, palladium, barium sulfate. So this reduction will be considered as Rosenmund reduction. Rosenmund reduction. If you are taking, if you are taking reducing agent like SnCl2 oblique HCl, this will be Stephen Stephen reduction. Stephen reduction. You can take it the third, which is Di Dibal DIBALLH diisobutyl aluminum hydride. Diisobutyl aluminum hydride. Clear? DIBALLH. You can take this ones. So see that you can use here three reducing agent. In the case of aldehyde, one to one we will see. Suppose we have aldehyde, we have this Rosenmund. So the first one is Rosenmund reduction. Rosenmund reduction. Rosenmund reduction. So in the
Yes.
case of Rosenmund reduction, we can take. So here we can take acid chloride, and acid chloride is the benzene, suppose, and this benzene is having C double bond OCl. Clear? So this is what benzoyl chloride. The name of this one is benzoyl chloride. So this benzoyl chloride undergo reduction. It means it will react with hydrogen, undergo reduction with palladium and barium sulfate. BaSO4, barium sulfate. So the product will be what? HCl, and this another hydrogen will be added to that carbon. So very simple reaction is this: C double bond O H, and this will be HCl. It's a benzaldehyde. Benzyl, benzyl dehyde, benzaldehyde. And you can do.
Sir, your voice is breaking a lot.
I am having a good net. I think there should be no any issue. No problem. Voice is
Sir,
cracking.
your voice is cracking, and my net is also showing full. So I don't know, maybe app problem or what, but your voice is cracking a lot, sir.
Okay, now see that if further it will happen, so you tell me, I will do something. Okay,
Okay, sir.
I will do something. Just a minute. Then
Sir,
okay,
it's okay.
so I close. I'm going to close my video. Let's watch it.
Yeah, maybe that is the reason.
Now tell me, now it's fine. Okay, so I think this Rosenmund reaction is fine, correct?
Yes, sir.
Okay. After this Rosenmund reaction, we have see that second Stephen reduction. This naming reaction is very, very important. Stephen reduction. So here you can take the nitrile. Okay. Now the question comes that if you are going to do the reductions, so here reduction will be by reducing agent, but whom we will do the reduction. So here you have to use the acyl halide. You have to use the nitrile cyanide. You have to use ester. Three things. So try to do the reduction. So see if the acyl halide undergo reduction with this palladium and barium sulfate. So the reaction will be Rosenmund. And Stephen reduction. In Stephen reduction, the reducing agent you have to use SnCl2 plus HCl. You have to remember this one. Don't try to write the Stephen reduction to Rosenmund reductions. So here you can take the nitrile like RC triple bond N. It's the nitrile. So when it will undergo reduction, so reduction means you will get the hydrogen. So how you will get the hydrogen? So this hydrogen will be provided by reducing agent which is SnCl2 and HCl. Clear? So here the two number of hydrogen, this bond will undergo cleavage and one hydrogen will be added to this carbon and other carbon hydrogen will be added to nitrogen. So you will get RCH double bond NH. NH. Clear? This product you will get. And now after hydrolysis of this one, it will undergo hydrolysis H2O. It will react with hydrogen, water hydrolysis. This entire H2O molecule will be eliminated. NH3 molecule will be eliminated. See that this is NH3. NH3 molecule eliminated, and the by means the product which you will get that is RCHO now, which is aldehyde. Any confusion? Any confusion?
No, sir, understood.
Hmm. This can be also reduced by this by Dibol, Dibal. The full name of his Dibol is diisobutyl aluminium aluminium hydride. Aluminium hydride. This is the reducing agent. You will get hydrogen. When you see the structure of this one, so structure will be diisobutyl aluminum hydride. First you write the aluminium, write the hydrogen, so it become aluminum hydride. Then two times you just write the isobutyl. So isobutyl means what? The second carbon has, the last second carbon has CH3. last second carbon has two CH3. So here, if you are taking just a minute, last second carbon, so this is your last carbon. Last second carbon has two CH3. This is isobutyl. This is the carbon having two CH3, which is attached to the aluminum. Now you can valence CH3, 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 CH3. So it's the iso, no? Sorry, it's a new butyl. Do you know the meaning of this iso and neo? See that iso means what? By mistake, I have written neo. Iso means what? The last second carbon has one carbon. Clear? And neo means what? The last second carbon has two carbon. So if it has two carbon chains, so it will be the neo. So here you have to write iso, not neo. So you can write only one carbon attached to this one. Only one.
Sir, can you tell
So,
again once this what you were doing? I didn't understand. Your voice was breaking.
what I said that iso means what? See, iso means what? Iso means last second carbon has one CH3. Last second carbon has one CH3 group. So this will be iso. And neo means what? Last second carbon has two CH3. Like carbon, 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 carbon. And if you are writing last second carbon, like first and second, suppose here you are writing one carbon. So this is iso and one, two, three, four, five carbon. So pentyl, isopentyl. If you are writing one, two, three carbon and last second carbon has one CH3, so this is iso and total four carbons, so it will be isobutyl. Any confusion?
Okay.
Iso is clear.
Yes,
And
sir.
when we talk about the neo, just put double carbon. Like carbon, carbon, if you are writing, last second carbon means middle carbon has two side carbon chain. This will be neopentyl. Neo and count the total carbon, it will be pentyl. So this will be the neopentyl. Any confusion?
No, sir.
So the same I'm telling you that if you wanted to draw the structure of this isobutyl aluminum hydride, so you can write the aluminum and then hydrogen and iso two times isobutyl. So here this is the carbon has one side CH3 and C here iso. This is CH3. This is CH. So this is what diisobutyl aluminum hydride. This is the reducing agent, and this reducing agent can reduce the nitrile. You can take the alkyl nitrile like RC triple bond N, and if you are taking DIPALH, so it means this hydrogen you will get, and this hydrogen will be added along with the triple bond. So this triple bond, one bond will break and one hydrogen will be added to this carbon and the second hydrogen will be added to nitrogen. So you will get RCH double bond NH and this will undergo hydrolysis H2O. So you can see that this ammonia will be eliminated RCH double bond O, RCHO and then ammonia byproduct. So this is the aldehyde you will get. Any confusion? See that this dibal will not reduce the double or triple bond. Only this cyanide will be reduced. Note point. Note dibal dibal H cannot reduce cannot reduce carbon double bond carbon or carbon triple bond carbon. It can reduce only carbon triple bond nitrogen, not carbon to carbon. So suppose if you are taking any example of R CH where double bond CH is there and then CH2 and then C triple bond N. And if you are writing here Dibal, Dibal H isobutyl, Dibal H isobutyl twice. Also I can write here Dibal H ammonium hydride, ammonium hydride isobutyl twice, isobutyl twice. Here this hydrogen will reduce to this triple bond carbon and nitrogen, not carbon carbon double bond. This will not reduce. So here you will get RCH double bond CH, CH2, C double bond NH, and here also H. Now again same way you can put H2O molecule. So if you will add H2O, so ammonia, ammonia
Sir,
eliminated,
I,
and now you will get product RCH double bond CH, CH2, CHO. Yes, tell me, you
sir,
are
this
saying
Dibar
something.
is yeah, this Dibar H is same as aluminum hydride isobutyl that which you wrote, right? ALHIBU twice. That one same as Dibar H, right?
The ball full name is diisobutyl aluminum hydride. So this is also diisobutyl aluminum hydride.
But sir, why did you write it
Then
same thing two times then?
in the examination, you will get either the top one or the down one. So don't be confused. You should understand that both are the same thing. That's why I've written.
Okay. Sir, once again, I will just copy this reaction which you have written because in textbook it is really difficult.
Okay.
Now, sir, on the reagent side, I should write any one of them, right?
Yes, anyone, anyone.
Okay. Okay. Done, sir.
Okay. Hmm. Okay, so done thing. Now see that the same debal can reduce ester also. So reduction of ester. So dibal can reduce ester also. So if you are taking ester like R, C, double bond O, O, R dash, it's ester. So when it will undergo reduction, so reduction means supply of hydrogen, and who will supply? So the reducing agent is D bal, D bal H. So what you will get? So here after reduction and followed by hydrolysis, you will see that how it will get reduced. So here it will break and one hydrogen will be added to this oxygen and one hydrogen will be added to this carbon, carbonyl carbon. So
Okay.
you will get R, C double bond O, H, aldehyde, and R dash O, H, which is alcohol. So you will get alcohol as well as aldehyde. Aldehyde will be the main product, major product. This is your main product and main product, and alcohol will be byproduct. So this is about the ester. Now, if you are taking the value of R, suppose CS3. If you are taking R is equal to CS3 and R dash is equal to C2H5. So now can you tell me that
Can you
what
give
will be the name of product? Name of product? Yes.
sir? Can you just give me 1 minute and I'll come back?
Yes, you do it. You do it and share in the WhatsApp group. I'm here.
Okay,
I
sir.
will check it.
Sir, I will just come back in a minute. After that, I will share it. Okay.
Okay, okay, okay. I will wait. Go.
Done, sir. I've shared it.
Okay. So let me check it. Hmm. Yes. So what is the name of this compound? Methyl what?
Aldehyde, right?
Methanol? No.
Sir, CH3 group means methyl and aldehydes.
So how you will get CH3? R, acha, right. Ethanol, yeah, fine. It is ethanol, acetaldehyde. Two carbon is there, na? CH3, CHO. So two carbon, ethanol, ethanol. Two carbon is eth, and just add al, ethanol. Got it?
Okay, sir.
Hmm.
Sir, when
Yes.
would it be methyl?
Methylaldehyde is not there. Methanol or formaldehyde, one carbon. CHO, HCHO. If only one carbon hydrogen is there. So, because here if you are taking ester, so if you are keeping here CH3 at R, so this carbon is also included na, in the product,
Yes.
this R and C. So it become two carbon. So aldehyde of two carbon is acetaldehyde. Aldehyde of one carbon is formaldehyde or methanol. This is correct.
Now, sir, should like, I remember you telling me that in IUPAC name you should not write full like aldehyde. You should write only Al. So over here, should I write ethanol only or ethanaldehyde?
Ethanol al. Ethanol. So this is IPSC name. Ethanol is IPSC name. And if you are writing uh, that one, so it will be acetaldehyde. Acetaldehyde. And in case of one carbon, it will be meth. And AN, remove E, add al. Methanol. Or this is also common name is formaldehyde, not methanol. Formaldehyde.
So, sir, this ethanaldehyde is not correct.
Ethanaldehyde is not there. Acetaldehyde is there.
So, sir, either I can write acetaldehyde or I can write ethanol.
Only you have to write acetaldehyde in the as the common name. Ethanol will be IPSC name. If you are writing ethanaldehyde, ethanaldehyde, so it is wrong. You will get 0 marks.
Okay, okay.
Uh, So now the next method of preparation from the hydrocarbon. So should we start? Third one from hydrocarbon. Hydrocarbon. So how can we prepare it by hydrocarbon? So aromatic aldehyde and its derivative can be prepared. So you can use it first by oxidation. Oxidation. So in the case of oxidation, you have to use chromyl chloride. chromyl chloride. If you are using oxidizing agent chromyl chloride, so the reaction will be called as E-tart reaction. E-tart reaction, which is very, very important. This reaction is very, very important for the board. By name, uh, the, the question will come by name only.
Yes, sir. I
Second is,
also it in the paper
so
previous.
second by Jones reagent. You can take chromium oxide. So by chromium oxide, you will get the product. Or you can see the second one is the by oxidation. First, let me complete. So by oxidation, make chromyl chloride. So see that chromyl chloride uh, react with, suppose methyl benzene is there. It's methyl benzene. This is benzene, and this is hydrogen, hydrogen, and hydrogen. It's a methyl benzene. Any confusion? Which is called a toluene. This is methyl benzene. The name of this compound is methyl benzene. And this methyl benzene, when react with chromyl chloride, dioxygen, chromium dioxygen, clear? Then Cl, Cl, chromium dioxygen, dichloride, chromic chloride, CrO2, Cl2. So when this will react in the inert medium, which is carbon disulfide. In the inert medium carbon disulfide, you will get complex chromo, chromium complex. How to see that this hydrogen will be added to this one? This hydrogen will be added to this oxygen. Now it become what? OH, and this bond will will break, and this chromium will now join with the carbon.
Yes, sir.
So what will get? Benzene, and this is CH, CH, and now what will be the product? H, you can add it, chromium, OH, double bond O, Cl, Cl, Cl2. Am I correct? Any
Yes, sir.
confusion? In again, it will react with chromium, double bond O, Cl, Cl, chromyl chloride. Again it will undergo oxidation. What you will get? Again there is a hydrogen and double bond. So this double bond will break. This double bond will break, and this bond carbon hydrogen will break. Hydrogen will bind to the oxygen, and carbon will bind to the chromium. So you will get the same thing, which is benzene, and this is CH, Cr, double bond O, OH, Cl, Cl. Am I correct? Two
Yes, sir.
times, twice, because one more this group will be added upper side. Now this will undergo hydrolysis, HOH. So in the case of hydrolysis, what will be there? In the case of hydrolysis, see this is HOH. In the case of hydrolysis, you will get this one. Let me write First, oxygen like this. Oxygen, hydrogen, hydrogen. So here you will get chromium hydride. Since two types are there, so you take this one. And this oxygen will be added to this carbon. So what will be the final product? The final product will be benzaldehyde, CHO, and byproduct will be what? Chromium, OH, double bond O, Cl, Cl two times, and this hydrogen will be added to the chromium. Any confusion?
No, sir.
So this is the detailed reaction. How see that how this reaction involved in the oxidation. And in very short, you can write because no one is going to ask about the details.
Yeah.
In the main exam, if you will get this question in 1 marks or 2 marks, you can write the only reaction with reagent. Like direct you write the toluene, direct you write the toluene, and on the arrow you can write it. It's a CrO2. So this is oxidizing agent, and this oxidizing agent will oxidize carbon, this carbon. So it will change to aldehyde directly, CHO. This is your main product, which is called Itard reaction. So Itard reaction is this one. Any confusion?
Sir, but this one is too small, right? In the textbook, they wrote it like how you wrote, but non-expanded. It is simplified.
Yes, but the first one which I have written, it is in details.
Yes, sir, but the other one which you wrote, that is too small. So I think,
Why I have written too small? Because sometime in conversion, this reaction is always coming. In the conversion, only you have to write the reagent and write the main product. Don't try to go through the intermediate reaction. You have to write the main product like this. So both way I discussed here, you can apply
okay, sir.
as per the situations. Okay.
Sure, sir.
Hmm. Now the same you can use it Jones reagent by CrO3. It's same carbon hydrogen. And if you are taking oxidizing agent like CrO3 and CS3CO twice O, it means it's a acetic anhydride. The detailed structure is like this: C double bond O, C double bond O, CS3 two times.
So
So this is oxy.
CO3 is that Jones reagent, chromic oxide.
C, C CO3 is not CrO3. So
Yes, sir,
that
I'm
chromium
asking
oxide,
CrO3 only. That is Jones
yes,
reagent, right?
Jones reagent, yes, in acidic medium. But here it is written in medium ester. The temperature you have to take a very cold temperature like 273 Kelvin around temperature. Okay, so 0 to you can say 0 to 10 degrees Celsius you have to take
Okay, sir.
0 to 10 degrees Celsius temperature. So here it will get oxidized. Here it will get oxidized, and how see this is oxidizing agent. Oxidizing agent will form alcohol. Will add here. So if I will take two times, so OH, OH, and two OH is not possible at the same temperature, means same condition. It become unstable. So in this case, this HOH H2O eliminated, and now you will get the main product CH double bond O. If you are suppose if you are not adding this acetic anhydride, hydride, so you will get the carboxylic acid. So here to stop the reaction, to moderate the reaction, you have to add this acetic anhydride in the reaction mixture. So this is the product. Any confusion? Next, Gutterman-Koch reaction.
Yes.
Side chain. Next one is the side chain. Side chain halogenation. So in the case of side chain halogenation, this is benzene and hydrogen like this. Now when you do the chlorination in the presence of sunlight, so HCl eliminated. If you take two molecules, two HCl. So two HCl eliminated, and now this is benzene molecule, one carbon hydrogen, and two chlorine, like this. Any confusion? So this is what benzyl chloride, benzyl, benzo. This will undergo hydrolysis H2O. So in the case of hydrolysis, this HCl is eliminated, and the main product will be
Okay, then that
CHO.
oxygen will attach to CH.
Yes. So now it become benzyl. Any confusion?
No, sir, understood.
Now, Gutterman-Koch reactions. That is, the name is reaction is very, very important. Very, very important. Gutterman name is very beautiful. Gutterman-Koch reactions.
Yes, sir.
Hmm. Gutterman-Koch reactions. So here you can see it's a very simple way. The benzene react with, well, carbon monoxide in the presence of, you can take any catalyst like SCl, CuCl, or AlCl3, any Lewis acid, or ZnCl2 also you can take. So there is a hydrogen. This hydrogen and CO will form compound like CHO, which is benzene direct. It will not break. CO will be added to this hydrogen. It will be CHO. Any confusion? This reaction is Gutterman-Koch reaction. Fine.
Yes, sir. And
Hmm.
this one, instead of asking to write the Gatterman coach reaction, our teacher instead told to write convert benzene to benzaldehyde. So like that also I think they can ask.
Benzene to benzaldehyde is Gutterman-Koch reactions.
Yes.
So if you are doing the reaction like this, the same reaction will be Gutterman-Koch. Now only preparation of ketone is there. So see the preparation of ketone.
So we'll do
So
that
when we
now.
talk, we can do in the next class if as you wish.
Yes, sir.
Okay, we can do. So in the next class we'll do the method of this one and the physical and chemical property. So the next class will be on
Sir, next class will be on Tuesday, right?
so Tuesday 10 time.
Yeah, yeah, Tuesday 10. Okay.
Uh, Tuesday 10 o'clock. So thank you. Good night.
Thank you so much.
You can. Thank you so much. You can leave the class.